You touch a table and it feels solid, hard. You yield and you don't question it. Of course it's solid. That's what solid means. You can knock on it, you can pass your hand through it, end of story. Except that's not an explanation, that's just a description. And when you ask what solid actually is, what's really stopping your hand from going through the table, the answer you think you know starts to fall apart. Most people imagine solidity as density, lots of stuff packed tightly together. Atoms squeezed so close that there's no room to get through. That feels reasonable, obvious even, but that's not what's happening, not even close. And that should bother you, because when you look inside the table, when you really look, there is almost nothing there. Think about an atom. You probably picture a tiny solar system, a nucleus in the middle, electrons orbiting around it. That picture is already misleading. But let's go with it for a moment. The nucleus is incredibly small compared to the size of the atom. If the atom were the size of a football stadium, the nucleus would be a grain of sand at the center. Everything else is empty space, vast emptiness. Now multiply that emptiness by every atom in the table, then by every atom in your hand. And now ask the question again. Why can't your hand pass through the table? Because the atoms repel each other, people say. But it isn't one. Repel how? At a distance? Through empty space? What does repel even mean when nothing is touching? This is where everyday intuition fails completely. Richard Feynman liked to point out that the word solid tricks us. It sneaks in an explanation without doing any explanatory work. We use the word as if it names a thing, when it's actually just a summary of behavior. And once you stop accepting the word and demand the mechanism, reality gets uncomfortable. When you press your hand against the table, your atoms never actually touch the table's atoms, not once. There is no contact in the way you imagine contact. What's happening instead is an interaction between electric fields. Every electron carries electric charge, like charges repel. When the electrons in your hand get close to the electrons in the table, their electric fields push back. That push is what you feel. Solidity is not matter touching matter. It's force without contact. Think about that. The thing you call solid is actually a balance of forces acting across empty space. The resistance you feel is not hardness. It's electromagnetic repulsion. The table feels solid for the same reason two magnets feel solid when you try to push them together. You don't say the magnets are touching when they push back, yet with the table you do. Why? Habit, language, comfort. Now pause here, because this is the point where people usually object. They say, fine, it's electric forces, but the table is still real. It's still there. But the way it's there is not the way you think. And that difference matters. Because electric forces don't just resist motion, they define structure. They decide where atoms can sit relative to one another. They determine the shapes of molecules, the rigidity of materials, the difference between air and steel. Solidity is not a property of matter itself. It's a pattern of forces in equilibrium. This already undermines the everyday picture, but it goes deeper. Why do electrons repel each other in the first place? Why did they form stable structures instead of collapsing? Classical physics had no good answer. If electrons were just tiny charged balls orbiting a nucleus, they should spiral in and crash. They don't. Atoms are stable. Matter persists. Something else is at work. This is where quantum mechanics enters, and not gently. Electrons are not little balls. They don't have precise positions the way objects do. They exist as probability distributions, clouds of possibility. The electrons in an atom occupy states, not orbits. And these states have rules, very strict ones. One of those rules is the Pauli exclusion principle. It says that no two electrons can be in the same quantum state at the same time. This is not a force. It's not a push or a pull. It's a constraint, a rule about what is allowed. And this rule is responsible for most of the solidity you experience. When you try to push your hand into the table, you're not just fighting electric repulsion. You're trying to force electrons into states that are already occupied. The universe doesn't permit it. Not because it's difficult, but because it's forbidden. Let that sink in. The table resists your hand, not because it's made of tightly packed stuff, but because the possible arrangements of electrons do not include your hand being there. Solidity is not material. It's logical. This is where intuition really breaks. We're used to thinking that rules describe what things do. In quantum mechanics, rules decide what things can be. The structure of matter is not enforced by contact, but by permission. Feynman emphasized this because it flips the entire picture. The world is not made of solid building blocks bumping into each other. It's made of allowed and forbidden configurations. What you experience as hardness is the universe saying no. Now let's push this further, because the word real is still hiding something. You might think, okay, the table is mostly empty space, but the fields and rules are real. So the table is still real. Again, fair enough. But now ask yourself what you mean by real. Is a magnetic field real? You can't see it. You can't touch it directly, but it can deflect a compass needle. It can exert force. You call it real because it has effects. Electric fields are the same. Quantum states are the same. Reality, at this level, is not about substance. It's about influence. This brings us to the midpoint where intuition collapses. You think of objects as primary and forces as secondary. First there's the table, then it exerts forces. Physics says the opposite. The forces and fields are primary. The object is a stable pattern within them. The table is not a thing that has solidity. Solidity is a behavior that emerges when fields and quantum rules arrange themselves in a particular way. That's not philosophy. It's measurable. Change the arrangement slightly and the solidity disappears. Heat the table enough, it softens, then melts, then becomes a gas, then a plasma. The atoms don't vanish. The rules don't vanish. The pattern changes, and with it, the sensation you call solid. Even more unsettling, under the right conditions, the same atoms can behave in completely opposite ways. Superfluids flow without friction. Superconductors carry current without resistance. Matter that should be solid refuses to behave like it, so solidity is not guaranteed. It's conditional. Now ask the deeper question. If solidity is not fundamental, if it's an emergent behavior, then what is fundamental? Feynman would say, stop asking for substance, ask for rules. The universe is not built from stuff in the way a wall is built from bricks. It's built from relationships, from constraints, from symmetries, from allowed transformations. Matter is what those rules look like when they settle into stable arrangements. This reframes the entire question. The original question was, why does reality feel solid? That's the wrong question. It assumes solidity is a basic feature that needs explaining. It isn't. The better question is, why do certain interactions produce the sensation we label as solid? And the answer is not because things are hard. It's because quantum rules, electric forces, and the exclusion principle create stable configurations that resist change. Your hand doesn't pass through the table for the same reason you can't write two different letters in the same place on a page at the same time. Not because the paper is solid, but because the rules don't allow it. Once you see it this way, other things fall into place. Why does a chair support you? Because the electromagnetic forces between atoms arrange themselves into a configuration that balances gravity. Why does glass shatter, but rubber bend? Different energy landscapes. Different permitted rearrangements. Even the distinction between solid, liquid, and gas starts to look superficial. They are not different kinds of stuff. They are different solutions to the same equations. And this isn't speculation. We test this constantly. X-ray diffraction lets us map the arrangement of atoms in solids by bouncing waves off the electron clouds. Electron microscopes don't see hard particles. They see probability distributions. Particle accelerators probe matter at energies where solidity vanishes entirely, replaced by fields and interactions. Every experiment points the same way. The closer you look, the less stuff you find. What you find instead are patterns that persist because changing them requires energy, and the universe prefers the lowest energy arrangement available. Stability masquerades as substance. So when Feynman said reality isn't solid, he wasn't being poetic. He was being literal. Solidity is a useful illusion, tuned perfectly to human scale. It works for building houses and sitting in chairs, but it is not how the universe is put together. The unsettling part is not that the table is empty space. It's that emptiness, governed by rules, can behave like a wall. That should bother you. Because it means reality is not made of what it feels like. It's made of what it allows. And this is how science keeps moving forward. Galileo questioned falling objects. Newton connected motion and force. Maxwell unified electricity and magnetism. Quantum mechanics replaced particles with probabilities. Each step didn't add comfort, it removed assumptions. Each discovery didn't tell us what the world is made of in a familiar sense. It told us that the familiar sense was misleading. Reality feels solid because the rules of the universe conspire to make it feel that way at our scale. But that feeling is not a guide to what's fundamental. It's a side effect. The universe doesn't care how it feels to you. It only cares that its rules are satisfied. And when they are, you get tables, hands, and the illusion that one is stopping the other by contact. That illusion is good enough to live by, but it's not good enough to understand by. And understanding has always required letting go of what feels obvious and following what the rules demand, whether or not they make sense to us.